Hello everyone. In our previous session, we discussed about number, its characteristics, properties, and function. Today, in this video lesson, we are going to see all those points in action. So let's get started and switch to Visual Studio Code. Okay, we discussed that infinity, minus infinity, and NaN are special type of numbers. This is pretty straightforward. I will expect you guys to go and uh, play around with these numbers and see how they behave in different scenarios and with different computations like addition, subtraction, division, and multiplication, and I'm sure you'll be able to understand how and when to use these things, and you can let me know if you think that you have any questions, and I will be happy to assist. Okay, we'll move to point number two. We said that big integer values with greater than 15 digits are not always correctly represented. So let's actually prove that. uh, we discussed also the 64-bit representation that JavaScript uses to represent a number, and out of those 64 bits, 1 bit is for sign bit, 11 bits are for exponent, and 52 bits for mantissa or significant. Here I have added plus 1 as well. This there is actually there are 53 bits that are used to that are used to in for mantissa. The this one digit, this extra bit is not a part of 64-bit representation, but when we calculate the value of the mantisha, this value is always used. So this is always a hidden but an extra bit. In actually there are 53 bits in are used for the mantissa, but in 64-bit format only 52 bits are used, and this extra bit is only used when we try to calculate the value. When JavaScript internally tries to calculate the value, then that extra bit is used. So we will talk more about it in detail in the next session when we'll discuss about this format, and we'll go through an example. We'll try to convert a number to its 64-bit format, IEEE 754 value. Then it will make more sense to you. So for now, you can just assume that in actual we use 53 bits for the mantissa or the significant. We know if there are 53 bits, then the largest binary value we can represent is uh, math dot power 2 to the power 53, sorry, 2.53 and minus 1. So let's print it. And let's see, this is the value that we get. So this is the maximum value that can be represented by JavaScript. And if we try to print number dot max safe integer, this is the same value we will get. Okay, so these two values are similar. Now, since we know that this is the largest value that can be represented by 53 bits that we used for mantissa, so if we go beyond this value, then we know we are going to require extra bits, and when we require extra bits, these extra bits value we cannot control. These extra bits value are always 0. So no matter how many digits we require, they will always be 0, and we cannot change their value. So that's why we are able to represent some value which are beyond this range, but we are also not able to represent those integer values for which we require those extra bits to be 1. So we will go through one example here. Let's try to take this number itself, the maximum integer number, and I will assign it to num equals to this. Okay, and I'll try to console.log num. Okay, but before we do that, let me try to add 1 here on this number, and let's see what happens. So okay, this has successfully added the number, and it is also uh, being represented correctly by the JavaScript. So when we use this number, only this number, then we know that all 53 bits are 1. Okay, but as soon as we add 1 in this number, there is a 54th bit will be required to represent that value. And as I mentioned earlier, that the extra bit, the 54th bit that will be required, will be always 0. So that's why we can see that this number is represented correctly, because the first bit will be 1 and the remaining 52 bits will be 0, and then this extra bit will also be 0. So that's why we are able to represent it. But let me add 1 here. So now this number will require the extra bit to be 1, which is not possible. So we will not be able to represent it. There you go. So it has only given me the result when we added value 1 on this number. So you will be able to understand it in more details, more precisely, when we will talk about this format in our next session. So I will leave it here for now, just so that you understand that uh, when we try to use values greater than the maximum safest integer possible in JavaScript, then JavaScript cannot guarantee, because of the mechanism it uses internally to store the value. Okay, so let's talk about the next point, that the maximum precision value is 17 in JavaScript. So JavaScript doesn't allow any number to contain more than 17 digits, and it's because of the same reason that Mantissa part require 53 bits to represent it internally. And if we try to use a larger value, then that value will require more number of bits. So that's why the restriction is there. And when we will be talking about the double precision 64-bit format that JavaScript internally uses to represent a number, then you will be understand it more precisely. So for now, we will go through an example. Let's take a number which has more than 17 digits, and let's try to print this number. So when we will print this number, then we will see that only 17 digits will be considered as a precision, and the remaining digits will be left by the JavaScript. So if we count these numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and 17. So in total, the 17 digits are there. So because if we use more digits, then they will require more number of bits, which is not possible. So we cannot represent them. And JavaScript makes sure that only 17 digits can be represented. Okay, so the next point is JavaScript numbers are stored as double precision 64-bit format IEEE 754 value. So we are going to discuss this point in a separate video session, where we will be going through in detail how JavaScript internally converts a number to double precision 64-bit format, and we'll go through an example. So then you will be able to understand minute details about the internal representation that JavaScript uses, and you will also be able to understand why there are some restrictions, why large values cannot be represented by JavaScript. So we'll talk about in a separate video session. Okay, so now let's talk about functions. We discussed about is finite and is NaN. So these functions are pretty straightforward. They can be used to check the validity of the number. If you use is finite function and pass any finite value, then it will return true. And if you try to pass any other value, like a string value or infinity or minus infinity, then it will return false. But if you try to pass any boolean value in this function, that will also be returned as true, because internally boolean values are converted to 0 and 1, and since 0 and 1 are finite numbers, so that will give you true. Similarly, is and n can be used. So they are pretty straightforward. You can see and check these functions uh, for different scenarios. Okay, so let's discuss about the next function, toString. We have already discussed about this function in our previous video session. So we know that this function is used to convert a numeric value or decimal value to different base types like binary or hexadecimal. So this is pretty straightforward, and I'm sure that you will find it easy to use. So similarly, parseInt and parsefloat are also pretty straightforward. We have also seen their use cases in the previous video session. ParseInt is used to convert a string to integer type, and parsefloat is convert a string to float type. Uh, and we have also seen how they are different from number function or unary operator. So they are also pretty straightforward, and we have also discussed about toFixed function, which is used to return the fixed digits after the decimal point. So uh, this is also a very easy function. I'm sure that you will find them pretty straightforward and easy to use. So please let me know if you have any questions about any of these functions. I'll be happy to reply. So that's it for today's video session, and thank you for watching, and see you in the next session.